Okay, I'm going to let f prime equal 4x cubed minus 12x squared. Identify where the extrema of f occur. Wednesday, this is what our handout is like. I'm giving you the derivative. I don't know the function, but I'm going to graph it. And I'm giving you an easy one because we know the antiderivative of this is a, in general, it's to the fourth power, right? Which looks kind of like a W if it's extreme, right? It's not extreme, looks like a parabola. Okay, so, but we're going to analyze this function to the point where I can graph f without knowing f. So I'm going to find where the extreme occur, and I'm going to go ahead, since we're practicing today, we're going to use the second derivative test. Yeah?
Sure.
So, first thing says set the derivative equals 0. Do not be confused. This is the derivative. Pay close attention as to what you are given. I am given f prime. So I'm going to pull out a 4x squared. I'm going to have x minus 3. So I get 0 and 3. You with me there?
Yes.
But just be very careful. I have a lot of people go ahead and find another derivative when they already give me f prime. So now, second part of the first root test. Just find the second derivative. What's the second derivative?
12x squared minus 24x.
12x squared minus 24x. Now, all I really care about, and I'm going to go ahead and factor this. I don't really need to, but it helps to plug in, right? So I want to know f double prime of 0, positive or negative?
Negative. 0.
0. F double prime of 3. Positive. So here I know what's going on if it's positive.
Min.
It's a min. What's going on here? Saddle. So when I answer the question, by the extreme values, there is a local min at 3, comma, oh, we can just say we're going to have to go with x equals 3. Right? No way to find the y in this problem, because I don't have f. No, because remember there's infinitely many antiderivatives. Yep. Yeah? Good thought, though. But wrong. Yeah. Questions here? Now notice I said nothing about the saddle, because the question did not ask me. A saddle is not an extreme value. But I need to point it out, because in a couple of questions here, I'm going to graph this. And that saddle is going to be useful when I graph. Okay. Now I want to find where f is increasing and decreasing. Let's find where f is increasing and decreasing. What should I do here?
Number line.
I should do number line. Actually, I'm doing the first order test, but I don't need the extremes, right? Do a part of the first order test. Which is nice because I already have the first order equals 0, right? Okay, so I'm going to kind of write it over here. What was it? 4x squared x minus 3?
Yeah.
And I ended up getting 0 and 3. Just kind of rewriting it so I have it on the same screen. F prime f. Remember, you need to label this. 0 and 3. Let's pick negative 1. Well, let's see. I'm going to have a positive and a negative. Excuse me, negative?
Yeah.
Yes. Pick 1. I'm going to have a positive and a negative, which is negative. Pick 4. I'm going to have a positive, positive, which is a positive. So decreasing, decreasing, increasing. And yeah, you should be like, yeah, completely makes sense because we know there's a saddle. It says decreasing, we know it's this kind of saddle, not this kind of saddle, right?
Yeah.
And then we know there's a min at 3. So let's write this up. So we are decreasing on negative infinity to 0 and 0 to 3. You do have to break it up like that because at 0 it's not necessarily decreasing. Increasing on 3 to infinity. I said I wanted to use a second to get practice.
Is there any way that we have to use a second?
When I flat out tell you to. But no, they tell you the same thing. They tell you the exact same thing, so no. But I just wanted to get practice on the second derivative test, since we've only done it once. But no, if I were starting this from scratch and I'd already had practice on the second derivative, I would have gone to the straight first derivative test. Okay? Let's find where the graph is concave up and concave down. Up like a cup, down like a frown. Find where the graph of f is concave up and concave down. So what am I doing here?
Concavity.
The concavity test. Which means the second derivative. So let's see, the first derivative was 4x cubed minus...
X minus 2.
Minus 12x squared.
4x squared x minus 2. Times x minus 2.
4x cubed minus 12x squared. Okay. Are you looking at the factored version?
Yeah.
We don't want the factored version because we want to take another derivative. Right? For concavity test, we need the second derivative test. So I want 12x squared minus 24x. Oh, we already found that too, didn't we?
Yep.
Oh, dang it. Which is 12x, so I have x minus 2. I get 0 and 2.
Yes.
Now, for the concavity test, we do number line that. And label it. F double prime, what does it tell me about f? 0 and 2. So if I pick negative 1, remember I'm plugging in here. Negative and a negative, positive. Pick 1, positive, negative. Pick 3, positive, positive. So it tells me it's up,
Up, down,
down, up. So let's write that up. Concave up on negative infinity to 0 and 2 to infinity. Concave down on 0 to 2. Now if this were the AP test, usually these are multiple choice, but if this were instant response, remember number line is not enough. You simply have to say concave down on 0 to 2 because the second derivative is negative. You have to actually explain why. I mean, literally just say what's going on. But we'll get more practice on that when we actually hit the extended response, which should be coming up here soon. We've got one more chapter under our belts and we're good. Yeah? Last thing, I want to sketch a possible graph for f. Just because you see the word sketch does not mean it is on paper. This is why you have the graph paper.
It should say artistically drawn.
No,
Graphic.
no.
That's the way you do it.
Okay. Now we can't be too specific. It says sketch a possible graph. Because we know that going backwards there are infinitely many answers because that plus constant, right? Remember, think about adding a number is your y-intercept, shifts it up and down, right? So I could have a graph really low, I could have a graph really high or the center, and they'd all still be right. So let's first get one thing down. If I go back here, I know at 0 there's a saddle, and at 3 there's a min, right? And sometimes it helps to sketch a little bit, then erase, sketch, erase, sketch, erase. Okay? So somewhere along 0 there's a saddle, and somewhere along 3 there's a min. So I'm just going to put my saddle, I'm going to make it easy and put it at 0, 0. I could put it anywhere though. I'm going to make my min be lower. But be careful, your min could very well be up here, correct? By the way, depending, not on this problem, but that can happen. So don't think that the min has to be below everything else. It could be up here and still be a local min, right? So it kind of helps. We're just sketching, and if it's wrong, it doesn't fit, we erase and adjust. Now I know from my increasing, decreasing, that I'm decreasing through that saddle, then I start increasing after 3, correct? Okay, so I'm decreasing and then I'll increase, right? But we have to be kind of specific because it's concavity. It changes at 0 and 2, correct? So here's 2. So somewhere along the lines, if I'm decreasing, I have to kind of change. So I'm going to kind of go, okay, I'm changing here. Saddle. I'm going to say, okay, at about 2, I'm going to change and go concave up. It's kind of hard for those inflection points to be accurate, but we can try our best. That looks like it might be changing it too. So here's a possible graph of F. And no matter where you put it, it should be look this way, but shifted up or down. So when I say possible, they all look the same. And we'll just shift it up or down. Questions?